As soon as I finish off a few outstanding projects, I'm going to take a little break from restoration to focus on some new test equipment, and I want to rejigger my workshop a little bit. Not only is it a mess right now, but I've also come to realize that just in practice there are some pieces of equipment I just don't use, and they're taking up space that could be occupied by more useful stuff. Plus I wanted to upgrade some of my gear for a while. So, first up, I've got a Sencor TC162. Sure, I got a bunch of tube testers, but there's a reason for that. For example, my oldest one would probably be the I-177 military tester. That can't do modern tubes. It doesn't even have a 9-pin socket in it, so it can't do like a 12AX7. But it's quality, it's a real transconductance tester, great for doing really, pre-war tubes basically, or early into the war tubes. Then I've got the Cardmatic that I like because I can quickly test a bunch of TV tubes. It's got cards, easy setup for all the commonly used tubes and all the TVs I work on from the late 40s into the mid 50s. And then I've got my Hickok 600A that kind of spans both worlds from the earliest tubes up until probably the early 60s or late 50s at least, and it has very extensive setup chart to handle many tube types. But it won't do compactrons, it won't do new Vistors, and it doesn't test for leakage very well. So that's why I got this guy, which is if not the last, one of the last Sencor ever made. Solid state, streamlined just for TV work. Very simple setup. And as you can see, it's got sockets for compactrons. And one of the ways or reasons this is quick and easy to use is they have multiple sockets, like for instance, 2 octal sockets. It's because they're hardwired for the most common filament configurations. You either use this socket or this socket. And generally you don't have to flip any of these. You just set filament voltage, almost always on 6, set the load, rotate this for shorts, and so on. It's real quick and easy to use. Now the seller said it was working, but I always take that with a grain of salt, because working can mean you turn it on and the light lights up, the power light, versus fully calibrated, recapped, ready to go. This is somewhere in between. I've got a little collection of tubes that I know are weak, or I know have shorts, or I know have a lot of leakage, and I've tried them out in this, and the meter generally responds properly, but the calibration's off. So a really good tube will be somewhere maybe in the white question mark zone, but a bad tube is definitely way down into red. A leaky tube does register leakage, and the shorts light does light up appropriately. I have found calibration instructions, so I want to go through this, check out the insides, calibrate it, get it good to go. Also, the reason I started doing this video right now is because of this box that just showed up. This is something I want to get for a long time, but the prices are always astronomical. It's a Sencor, I think an LC053 is the model. It's in inductance and capacitance analyzer. Sort of like that old solar capacitance bridge I show you guys all the time when I'm checking for leakage. This is a much more modern, digital, fancier version of that. Plus it can test inductors. It's very popular because although it's solid state, digital, it will still test the old caps for leakage quite well up to I think 600 or maybe 800 volts. So it's a true test. It puts full, commonly encountered working voltages on the caps. It also has a special mode for reforming electrolytics. And so they generally sell for hundreds and hundreds of dollars, especially if they're fully working and calibrated, like 500 plus. I got this one I think for about 40 bucks because it doesn't work. So I'm taking my chances. I've got the service info. It's pretty much all off-the-shelf components. Just your jelly bean common transistors like a 2N3904 or 2N2222, common op amps, and comparators and so on. So I'm gambling that even if there is a problem, I can fix it. And I've encountered some issues where it's got a bad power cord, it's got a bad fuse, quick repairs. So right now I just want to take a quick look at it, try not to get too distracted into trying to repair it right now. And then right now I'm bidding on a third item that I won't talk about until I actually win it. It was fairly well packed, wrapped first in small bubble wrap, then larger bubble wrap, then in a sea of peanuts inside of a box. So it didn't suffer any damage. Got the usual markings like you'd see from being in a repair shop for a while. So here it is, Sencor LC53. Does not have the probe, but I think that's fairly easy to mock up. I think it's a BNC connector with an outer shield, and then the inner part goes to the red clip for the capacitor. See, one of the problems with that solar tester, although it seems to check for leakage just fine, if I want to actually check the value, it's not that accurate. For the low picofarad range, the probes really affects the reading, and it only goes up to about 40 or 50 microfarads. This goes from 1 picofarad to 200,000 microfarad, 1 microhenry to 10 henries. So nice wide range for the testing there. And okay, 600 volts for the applied voltage test. A range switch there. Never actually used one of these before, I've just read about them. Manuals are available for free online. I'm happy that it comes with this gizmo. This is the special tool you need for reforming electrolytics. It's actually a magnet. There's a hidden switch on the front panel. And normally when you're testing a capacitor, you have to keep a button depressed. You have to keep this button held down. But if you place this magnet in the right spot on the front, it will engage an inner switch, and I think this light comes on, and it will lock it, so you don't have to keep this button held down, and it will form up the capacitor. Well, I just lost the item I was bidding on. However, right after I lost the auction, I noticed there was another one on eBay. It looked to be in the same condition with a buy it now, $30 less than the auction I just lost, so I just bought that one. What it is, it's a Sencor PR57, which is a combo isolation transformer and variac, with lots of nifty features like a nice big meter, overload protection, and other goodies. I'll talk about that when it actually arrives. Getting back to this, I just plugged it in. It's a modern-ish piece of equipment, so I'm not really worried about like caps being bad or anything. So let's give it a shot. I can kind of feel it hum when I turn it on. Oh, I just squeezed the top of the cabinet and the display lit up. Wow, this might actually just work as is. Huh, I'll go grab a BNC with alligator clips on it and see if this thing actually works. So I don't know what happened there. In the ad it said that it didn't power up. Well, maybe there's an intermittent connection inside. I don't know. I'm also not sure why it shows 290 something when I turn it on. Obviously, you have to read the manual. I think that you might just need to zero out the leads every time you turn it on. Let me get this thing to stay upright. Yeah, I think I'm doing this right. What I'm doing is I'm holding down the value button and I'm turning this lead 0. Now, I'm pretty sure what that does is it zeroes out the capacitance of your leads. So, I go all the way counterclockwise and it bottoms out at 20. Now this is not the original leads that came with this, so I'm going to have to tinker a bit to get it to really zero out properly. But anyways, I grabbed an assortment of new capacitors. This is a little dinky 30 picofarad. So it's showing 11 now. If it's working right, I expect it to be 40 something. $49. Okay, and if I disconnect the cap and do value again, 19 to 49. Sounds like 30 picofarad to me. This thing might actually be working right. Let's go for a much larger one. 225. That would be 2.2 microfarads. No idea why it shows 10 when I'm not pushing any buttons again. I need to read the manual. I'm sure it needs to be calibrated. Well, let's check the value. Alright, 2.1819 on the microfarad range. Close enough to 2.2 microfarads for me. And finally, I got a big old 2200 microfarad electrolytic. Alright, microfarad range, 2300. Alright. Well, for a meter that supposedly doesn't work and sold for 1/10 of what they usually sell for, seems to work fairly well to me. Obviously, it's a brief test, but, you know, the fact that it powers up and it seems to read values and probably just needs some calibration, that's pretty nice. I guess I'll grab a couple inductors now and check those out. I've noticed this number has been slowly dropping, so maybe this thing has a warm-up time or something like that. I don't know. Alright, so let's check some inductors. So this should be 4.7 microhenries. After I read the manual and I have more time, I'll talk more about this meter and what the ringing test means and how to check for leakage and all that. For now, let's just see if this thing works. It doesn't look, well, For a while it was in the millihenry, then it jumped to microhenry, and I've got a minus value. Oh, I just noticed the switch here. Looks like this has a mode for testing yokes and flybacks. That's cool. This is 120 microhenries, maybe 4.7 was just kind of outside its capabilities. Yeah, 0.1 microhenry, I don't think so. I need to do a little work on that, but I really don't ever test inductors, so I'm not that concerned about that part of it. And now finally the meter's all in triple zeros. Weird. I'll check this 30 picofarad guy again. Even though the meter's reading all zeros now, there's still a bit of an offset on the picofarad range. Alright, well, that was nifty. Alright, before anybody posts comments correcting me, yes, I was completely wrong about how this works. I guess I was thinking of how my Weller soldering station works, where they give you a little magnetic tube and you can put it near a place in the panel, and I think it locks in the temperature. This is far cruder. To actually use this, you insert it between the handle and the case, and this has a screw, like a screw jack that makes it longer. This simply depresses the button by applying pressure between the handle and the button. Has to be an afterthought from when they originally created this device. So that's how you use it. Alright, and to show you how it works in practice, I got an old twist lock electrolytic TV cap here that I pulled out of a set, and I know it's leaky. So, got the leakage button depressed now. This will show you the leakage in microamp. Right now, I'm only at 25 volts. There's 0 leakage showing. I'm going to increase that to 50 volts. 10 microamps of leakage, and then to 0 as the cap is forming up. Jump to 100 volts, 200 microamps, 110, 90, 80. And what you'll see as I increase the voltage in the cap, the leakage current will jump up and it will go down more and more slowly, and eventually it will level out at some non-zero value. In fact, I'd be surprised if you could find any vintage electrolytic that would have 0 leakage current. I mean, there is no theoretically perfect capacitor. They all have some leakage current. But a modern cap, like a modern plastic film cap, is very low, and you need something more sensitive than this, I imagine, to measure it. So right now I'm at 200 volts, and it's kind of leveled out at 110 microamps. Let's jump up, not 100, 300. Now you can let this sit for a lot longer than I'm doing right now. I let it sit on here for an hour or 2 or 3. This is rated for 450 volts, by the way. So I should be able to go all the way up to 400. Unfortunately, there's no 450. It just goes from 400 to 500. You could probably handle 500 briefly, though, or while testing. Because that 450 volt limit, that's, you know, in general use, you wouldn't want to have more than 450 on it for extended periods of time. But these things can handle a peak voltage for a while that exceeds that. Back down to 4 now. So if you want to try forming up a vintage electrolytic so you can continue to use it, let this sit on here for a while. Ideally that number drops and drops until it's at an acceptable level. Don't ask me what that current might be, it depends on your application. But for sure, the lower the better. I just spent a few minutes looking through the owner's manual for this device and picked up a few interesting tidbits. Amazing what you can learn when you actually read the owner's manual. For example, I was saying I wasn't sure what a good leakage value would be for an electrolytic. Well, there's a chart built in that tells you just that. So, for example, a 10 microfarad cap at say 400 volts, 380 microamps is what they consider the maximum allowable leakage. And they have the same thing for tantalum, and just some basic info about microfarads, nanofarads, picofarads, and some notes about how to use the device. Handy. Something else is this leakage range. While I was doing the earlier tests, I had it like this. For smaller caps and for plastic film caps, it should be in this position. Also did a little bit of reading about the probe and how to replicate one, since I don't have the original. And it turns out they used a special low capacitance type of coaxial cable, so I'm going to search around for a hunk of that. I don't remember what it is. It's RG something or another. Hopefully it won't be too difficult to find a few feet of that so I can make up a decent probe, because with just generic coax, whatever this is, it has too much capacitance. I'm never going to be able to zero this thing out properly. So the last thing I want to do in this video is let's try measuring a nasty old leaky paper cap and see what we get. I'll try to pick one out that still has long enough leads left on it. I can make a good connection. Alright, let's see, what's this guy? It's supposed to be a 0.1 microfarad 200 volt cap. Alrighty. So, first let's try checking the value. Well, even if it wasn't leaky, it's about 56% high. And right now I'm only in a 10 volt range, but what the heck, let's check for leakage. Hey, no leak. Oh, we even have leakage at 10 volts. That's just sad. In the manual they say for ceramic, for paper, for plastic film, should be 0 leakage. Not a little bit, 0. Let's just jump all the way up to 100. But 14 microamps. It's rated for 200 volts, so let's check that out. Overload. Oh, there we go. 48 microamps, 49, climbing a little bit. Obviously, that's no good. Here's another cap. Again, it's a 0.1, but this is rated for 400 volts. So the solar was nice in that it would tell you if a cap was leaky, and you could look at the blinking light, know that the more the light blinked, the leakier it is. But it's nice to know the actual current leakage value. Let's see about capacitance. So if you just had a modern low voltage capacitor meter, like for instance my digital multimeter that I use in all my videos, that can measure capacitance. If I was to just use that, I might think this cap was fine and the other one was fine, because yeah, sure, it's about 50% high, but that may be within the range of tolerance for a particular application. And I've seen the same thing in electrolytics. In fact, probably all of these caps in this box would check out as having capacitance, plus or minus maybe 50% or so of the stated value. You might think that they're all good. You really got to check the leakage at the voltage is rated for. 100 volts. Lots of leakage. All the way up to 400. Overload. We'll drop down to the high range. Almost a milliamp. Over 800 microamps. It's terrible. Might as well just call this a resistor, not a capacitor at all. I think I'll just go ahead and close out this video here, and I'll call this part 1. When the PR57 shows up, probably in a couple of weeks, I'll take a look at that guy and then start restoring these one by one.